Welcome all. In this session, we are going to discuss another different problem, which is ugly number, and there will be a part 2 as a continuation to this particular problem. So first, let's try to understand what is part 1, ugly number. So you are given an integer number. You just given a number, and you have to check whether it's an ugly number or not, and return true if it's an ugly number and false if it's not. So what is the definition of the ugly number? If a number is given n, which can be returned as a product of its prime factors, like primes. So if it's a and b are its prime factors, and whatever it can, if required, it can, like prime factors would be that number and 1. Like if it has some other factors, suppose c, like that. So the prime factors should be 2, 3, 5, not anything else. So let's try to understand with an example. What about the number n equal to 6? 6 can be returned as 3 into 2. 3 is a prime number, 2 into prime number, and this 3 and 2 belongs to this category. So this n equal to 6 is ugly number. So what about n equal to 14? N equal to 14 can be written as 7 into 2, where 7 and 2 are prime numbers which cannot be factorized into like prime form. So here 7 does not belongs to this particular category. So 14 is not an ugly number. How can we check a given number n is ugly number or not? So what we can do, we can consider these 3 numbers which is given. We can keep on dividing with any of these 3 numbers until a perfect division is possible, and at the end, if it converges to 1, that number converges to 1 by the continuous division, that is an ugly number. Here also, if n like can be divided into a comma b, a cannot be divided further, so it will eventually converges to 1. Similarly, if it is b, b cannot divide further because it will converges to b or 1. So like that, we can have a check. So let's try to write the problem straight away. So let me use a different color. Okay, so this is the class solution. This is the method inside the class, define ugly number. So what is given? If there is only one number is given, which is integer, and we are expected to return a boolean, that is true or false. And one more edge case is that if the given number is less than or equal to 0, that is false, because it's also mentioned that the n has to be positive integer. Also, one more thing I mentioned is that n can be mathematically expressed as 2 to the power a, 3 to the power b, 5 to the power c. So that's why we are continuously dividing. So let's try to continue with the code. If n less than or equal to 0, return false. Otherwise, we have to keep on going with the continuous division. For p in the list 2, 3, 5. This is how we are going to access this 2, 3, 5. And continuous division, we will be handling continuous division of either of these 3 numbers will be handled using a while loop. While n modulus of p equal to 0, that means we are checking whether a perfect division is possible from any of these 3 prime factors which is mentioned. If is that the case, then n can be updated as n double division by p. So this way the n will be updated, and at the end, if it converges to 1, that's true, it's an ugly number. If it's not, it's not ugly number. We can check one more statement, like after this loop gets over, we can check if n equal to 1, then return true. If it's not, then it's false. We can simply write that same thing in one sentence: return n equal to 1. So that's it. So what is the time complexity? So here time complexity is basically like it's keep on dividing further and further. So it's a bit complicated because it's all about that number, how far it's going to converge this to 1. So but since it has a branching thing, we can in general write time complexity to be log n, but its base will depends on how the branching happens. Then space complexity, we are not utilizing any of the extra space on it, would be 1. So with that, let's try to move on to its part 2. So that is ugly number 2. How can we solve that? First, let's understand the problem statement. So you are given another positive integer n, and you have to return the nth ugly number if at all you are going to write in a sequential manner. For example, if you are going to write in a sequential manner, 1 is an ugly number, 2 ugly number, 3 ugly number, 5 ugly number, 6 is an ugly number, 7 is not, 8 is an ugly number. So keep on writing. So basically this is a series of ugly number. So the question is, you are given n, which denotes nth term of the ugly number. You have to return basically nth term of the ugly number. If n is given as 10, you have to return the 10th term in this ugly number series. So how can we do that? So there is an easy way to calculate the ugly number, because we already know 1, 2, 3, 5 are the initial ugly numbers. So basically, whatever be the ugly number going to follow after this, that would be either a multiple of 2 or a multiple of 3 or a multiple of 5, and this should be arranged in such a way that whatever the multiple of 2, 3 or 5, whatever it's the minimum among these 3, that would be arranged. For example, 4, 6, 8, I'm going to write few of them. 10, 3 is like 6, 9, 12, 15, and for 5 it's like 10, 15, 20, 25. So out of this thing, let's try to see how 2 is the in this 2, 6 is the minimum out of this thing. So we can choose to have 6 here, then 6 is already exhausted. Then out of all this, next minimum would be 8, then 8 would be coming here. Then out of that, next minimum is 9, so 9 would be coming here. Next minimum is 10, so 10 would be coming here. So next minimum would be like I have to write the 2 series also. One would be 12, so 12 would be coming here. Like that we can fill it. So we can use some sort of intuition of a dynamic programming in this particular thing. Basically, we can solve this using a 3 pointer methods. For example, 1 pointer you can fix towards the 2's multiplication, another pointer here, another pointer here, and we can have a track, and we can append the ugly series up to the nth term, and we can return the last element in the series. That's how we are going to do. You will understand it better if you try to code it. So let's try to code this thing. So let me make a bit space for you by erasing some of the things which is mentioned here. Yes. So class solution define ugly number self given n which is an integer, we have to return another integer. So I'm going to start with an array which is 1. I already stored the first element in the series of ugly number, that is 1, and there are 3 pointers I required to capture where is the pointer in that. One is the p2, p3, p5. So everything should be assigned to 0. So in that case I should have written a bit differently. So p2 equal to p3 equal to p5 equal to 0. So this is done. Then after that, already first element is attached to this particular array. Then we have to start from the second elements. So for I in range of 1 to n, so this would be next 2, next 3. Oh sorry, the indentation has not been properly mentioned here. Okay, next 2, next 3, next 5. As I mentioned, these are nothing but dp t2 multiplied by 2 comma dp p3 multiplied by 3 comma dp p5 multiplied by 5. And out of this we have to select the candidate of the ugly number series. Next ugly number series would be the minimum among this thing. So next ugly would be minimum among the next 2, next 3, next 5. So this is how it works, and we just have to append whatever we want. Append next ugly, and we have to move this pointer once it is done. Like if next ugly, as the example I mentioned, once we have attached append, we have to remove the thing and we have to move the pointer forward. So it would be next, if next ugly is equal to if it was next 2, then we should have moved that pointer. So p2 plus equal to 1. Similarly, if next ugly was next 3, it would have been p3 plus equal to 1. Applies for the last pointer also. So once this is done, we have created the series of ugly number, and nth is nothing but the last element in the series. So we have to return that. So return dp of -1. So this is the solution. So what is the time complexity in this particular problem? So we are only using iteration once, and so time complexity is order of n. Space complexity, since we are using an extra array here to store the ugly number series which we created, so in that case it will be order of n. So with that I have explained the ugly number part 1 and part 2. So with that I am concluding. So thank you.